Good afternoon, students, all of you.
Good afternoon, sir.
Any pending is there? You write COF63 minus fluoride ion, weak field ligand. No electronic pairing or electronic reorganization against to Hund's rule not happening as it is present. So 6 ligands approaching, 6 vacant d orbitals. In that outer shell d orbitals utilized sp3d2. So that 4 unpaired electron, 4.9 Bohr manodon paramagnetic structure octahedral. Outer orbital complex, weak field complex, high spin complex, spin free complex. All the names you can give. While removing the electron, you have to remove the electron from outermost shell. Write this. Completed means tell me. Here ammonia act as strong field ligand. Other examples: cyanide ion, CO, etc. Here what happens means electron pairing or electron reorganization. Screen share Nara
Yes, sir.
takes place even against Hund's rule. So now you see here also cobalt plus 3 only, Nara. Cobalt plus 3 already you wrote, na? 3d 6. 3d plus 6. 1, 2, 3, 4, 5, 6. 4s, 4p. But electron pairing can take place even against Hund's rule. This is paired here, this is paired here. How many vacant are it all required?
6.
6 available or not, you see.
Yes, was.
So inner shell d orbital utilized. So d to sp3. sp3 d2 you know before only. Here only you are going to know d to sp3 in this way. D to sp3 also octahedral structure. D to sp3 hybridization. Got it? Then n value any unpaired electrons irukkaanga?
No, sir.
So
No.
mu value 0 means
Zero. Diamagnetic.
diamagnetic. Then outer orbital complex, inner orbital complex, inertial d orbital utilized hybridization lo outer side d orbitals.
Inner
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 side.
D.
So this is called as inner orbital complex. Strong field or weak field?
Strong field.
Strong
Strong
field complex. Spin freely present, spin paired.
Spin pair.
paradise.
Pad.
Spin paired complex. All these names are there, okay? High spin or low spin idi?
High spin. High spin.
Hey, plus of minus of plus of minus of plus of minus 0.
Low spin, sir.
Low spin, low spin complex. High spin means that should be plus of plus of plus of plus of plus 4 by 2, that is plus 2. That became 0. Low spin complex. The explanation. Write this. Strong field like this pairing occurs, weak field pairing not occurs. Other example for strong field also I provided here. You remember that strong field, weak field, what I provided? Accordingly, you answer.
Completed, sir.
Completed,
1 minute. 1 minute, sir.
Okay.
Completed, sir.
F minus weak field ligand. No pairing of electrons. FE Z value 26. 4s2 3d6. Then here what is present? Fe plus 3 nara. Fe plus 3 will be 3d5 na. 4s.
Yes. Sir, you are not audible.
Pairing, Ara?
Yes, sir.
Yes, sir.
So first we had to remove electron from
3D
4s. Screen shared or not, ra?
Yes, sir.
So it is becoming 3d5. 3d5 means how you will write 1, 2, 3, 4, 5. 4s. This is weak field,
Yes, sir.
so that no electron pairing, na? 4d, so that you had to utilize like this, sp3d2. So octahedral structure. Okay, you can write the structure also, if you want. But octahedral very well, you know, n is equal to
5. 5.
5, sir.
5.
mu value
5.9.
Paramagnetic.
paramagnetic. Then what other words you can use?
Outer orbital.
Outer orbital complex,
Weak field complex. Weak field complex.
weak field complex,
High spin complex.
High spin.
high spin complex,
Spin free complex.
spin free complex. In these orbitals, fluorine will donate the electron, those electrons will be filled up. Okay, if you are not showing or showing, no problem. Write this. Completed means tell me.
Completed, sir.
Solve this. Answer ra.
Sir, it is a strong field complex, sir.
Yes. Strong field ligand. Electron pairing occurs. Okay. Fe plus 2 ಇದೆ. 4s2 3d6 becoming 3d6.
D2sp3, sir.
Yes, 1, 2, 3, 4, 5, sixth one. 4p. But strong field ligand pairing take place even against Hund's rule. D2sp3 octahedral structure. Octahedral n value 0, value 0, diamagnetic, outer orbital complex. Outer inner? Inner orbital complex.
Inner.
Remaining names also continued. How many times we will write? Once I wrote, okay? Remaining low spin, spin paired, strong field complex, all carried here also. Next question also here. Now onwards you have to solve. I will correct it if any mistake there. Okay, na? In these 6 orbitals, electron pairs given by cyanide will be filled. Will be filled. After filling only you have to check. But I am not writing. Okay, na? Answer getting means tell Mira.
Completed, sir.
Next answer.
D2sp3, sir.
D2sp3, very good, correct.
One lone pair is there. One unpaired electron there.
One unpaired electron is present, even though low spin, strong field, one unpaired electron there. Actually, if not strong field, you will have 5 unpaired electron. Instead of that, one only came. Then some people will ask the doubt, sir. Previously, strong field, all diamagnetic we got, sir. How we got here paramagnetic, sir? Reason? Whenever odd number of species there, odd number of electrons there, automatically will get a paramagnetic character only, not odd number when there. Got it?
Yes, sir. Sir, inner orbital complex.
Yes. Other names also you tell me. What?
Strong field.
Strong field complex, sir.
Yes. Further.
Spin pair complex. High spin complex.
High spin. High spin now. Hey, don't confuse.
Low spin, sir.
Low spin, one only there, na? 5 should be there. Becoming 1 means low spin only.
Yes.
Yeah, Fe plus 3. Fe plus 3 is with 3d5, na? Otherwise, you write 4s2 3d6 la. This gone. This 1 electron 3d5. la. 1, 2, 3, 4, 5. 4s. 4p. So pairing occurs. 5 members. How many pairs you can make with 5 members? 2 pairs only possible. No, 2 pairs only possible. Odd number there. That's why. Then D2sp3. Octahedral structure. Octahedral structure. N value 1. After that, here electrons will be filled. Electron pairs. Mu equal to 1.73 Bohr-Manadon approximately. Paramagnetic. Inner orbital complex. What differences you noticed in above and below case, and what similarities you observed in above and below case? Both I want. Tell me.
So mu naught is not equal to 0. Change.
Mu is equal to 0. Mu is not equal to 0. Unpaired electron no. Unpaired electron irukku. Diamagnetic, paramagnetic. Is it dissimilarity? No similarities.
Both are
Hybridization shapes.
Hybridization same. Shape same. Inner orbital complex.
Inner orbital complex.
Strong field complex. Low spin complex. Spin paired complex. Got it?
Yes, sir.
Write this.
Completed, sir.
Completed, huh? Very good. Every question you can solve right here itself you can learn. Wherever doubt coming, I will give clarity automatically. Na? So no problem. Next one also you are going to try here. Nickel. How many completed? Sixth one. NaCl4 2 minus. The required clues already I gave. So no problem.
sp3 hybridization.
sp3, very good, correct. Structure.
No pairings.
Tetrahedral, no pairing. Yes.
Two
Unpaired
unpaired
electron.
electron.
Two unpaired electron. Mu value. Approximate. Two point eight. 1.73. 2.8. 3.9. 4.9. 5.9. Like this. There is square root of n into n plus 2. 2 into 2 plus 2. 2 into 4. 6. Root 6. Root 6 how much? So like that. Approximation enough. Okay.
Sir,
Nickel.
sir,
Screen not
mu
shared.
value 2.9. Sir.
Yes, 2.9. 2.9 or 2.8 you can take. Z value 28. S2D8. S2D8. Then nickel plus 2 there now here. The nickel plus 2. 4s2 2 gone. 3d8. 3d8 means how you write 1, 2, 3, 4, 5, 6, 7, 8. 4s free. 4p also free. How many orbitals required for Cl minus weak field ligand? No electron pairing. So 4 required na sp3. Tetrahedral structure. Tetrahedral very easily you can write. Bond angle 109.5. N value 2. Me value 2.8 or 2.9 Bohr Maradon. Paramagnetic. Then solve this. Any doubt in this means ask me.
DSP2, sir.
DSP2, very good.
DSP2, sir. Strong field, sir.
Strong field, correct.
Pairing occurs, sir.
Pairing occurs, correct. Square planar structure. ఇది completed ara writing students?
Yes, sir. Yes, sir.
Nickel +2. 3D8 you have seen already several times. Cyanide, strong field ligand. Electron pairing occurs. One, 2, 3, 4, 5, 6, 7, 8. Press 4p. But sp3 not undergoing. Why? Because strong field there na pairing taking place. DSP2. DSP2 hybridization, square planar structure. (90° on 80° bond angles. N value 0, mu value 0, diamagnetic. Next, that question is solved.
SP3 hybridization.
sp3, correct?
Strong field ligand, sir.
Strong field ligand, correct?
Pairing occurs, sir.
Pairing occurs, correct?
Inner orbital complex.
Inner outer not required. Why? sp3. Where d orbitals only not used. D orbitals only not used. You no need to say anything. Okay. Structure.
Tetrahedral.
Very good. Tetrahedral. ఇది completed ara? Nickel cyanide. Students. Nickel 0. Nickel 4s2 3d8. 3d 8. 1, 2, 3, 4, 5, 6, 7, 8. 4s 4p. 4s లో 2 electrons there nara. Strong field ligand. Electron pairing occurs. Even against Hund's rule, here off-bow rule also violated. Off-bow rule also violated. Before filling, yes. Here electrons paired everywhere. 8 to 2, 10 electrons filled. then sp3, then sp3. sp3 na tetrahedral. We can draw the structure now again and again. I no need to draw. I think n equal to 0, mu equal to 0, diamagnetic. Diamagnetic. Understand?
Yes.
Even against Aufbau rule also. Points law clearly not written, but examples they are writing like this. Even against Hunt's rule and Aufbau rule also violated raw here. Next is here you have to solve. Well, all of you following Nara?
Yes, sir.
Sir,
Ask
sir, D2 SP3, sir.
P2sp3. How many ligands? Check there.
5.
DSP3, sir.
DSP3 correct. DSP3 correct. DSP3 or sp3d structure same. What is that?
Square planar.
See the points in VBT.
Trigonal by
Very good. Trigonal bipyramidal. Can you draw the structure? TBB structure. Okay, unpaid electron, everything detail you tell me.
no unpaid electron.
Diamagnetic.
No unpaid electron diamagnetic. Very good, correct. Is it completed, Ara?
Yes, sir. Yes, sir.
Array, anybody not completed means clearly you tell me. Don't hesitate. Okay. Iron 0, Ra. Iron Z value you know already. 4s2 3d 6 Z value 26. That's fine. Then 3d 4s 4p. CO strong field ligand. Electron pairing occurs 1, 2, 3, 4, 5, 6. Here 2. Even against Hunt's and Aufbau rule also electron pairing taking place. Na? Fill up here 8, 1, 2, 3, 4, 5, 6, 7, 8. Then how many vacant orbitals required? 5 vacant orbitals required because 5 approaching there. DSP3 hybridization. So TBP, trigonal bipyramidal. FE, equatorial plane lo CO. Axial CO. Trigonal bipyramid. Angles 90, 120, 180. Unpaid electron 0, mu value 0, diamagnetic. You can say here inner orbital or outer orbital. Why? Because sp3d there, dsp3 there. Here dsp3, inner orbital. Understand all of you?
Yes, sir.
Write this.
Completed, sir.
Ta-da. All this.
SP hybridization.
SP, very good, correct. SP means what is the structure?
Linear. Linear.
Linear, very good, correct. Magnetic nature. Magnetic moment.
Diamagnetic. Mu zero.
Diamagnetic, correct. Yes. See the completed or above one?
Yes, sir.
AG plus 1 here. AG plus 1 configuration ra. 5s1 4d10 becoming 4d10, correct? 3d 4d idi.
4D. 4D, sir.
4d, are you catching this? 4d adi. Two ligands only approaching sp hybridization. sp hybridization means linear structure. Ag plus ammonia.
N equals to 0.
Ammonia, yes. Linear structure. 180-degree bond angle. N value 0, mu value 0. Diamagnetic. Inner orbital, outer orbital discussion not required. Update.
Yes, sir.
Sir, this.
SP3.
SP3, sir. Tetrahedral.
SP3 correct. Tetrahedral correct.
No unpaired electron.
No unpaired electron.
No pairings.
No pairing. No pairing. Huh? Already paired only. No discussion of that. Strong field or weak field or no discussion required. AgNH3 case also. Strong field or weak field or discussion not required. That's why I'm not writing, you see. That doubt when you will get some unpaired electron there. Pairing occurs or not, you will get doubt. Here already D10 means completely filled. Enna doubt. Adi strong field weak field doubt illa. So no discussion. Okay, va. That's why I not wrote strong field weak field. Z1 plus 2. Z1 plus 2 means automatically adi 3D10 ra. 3D10 means all are paired only. Then further pairing is not there. So weak field law, strong field law, this discussion or other. Understanding or time delay.
Yes, sir.
4 orbitals, sp3. sp3 means tetrahedron. N0, mu0, diamagnetic. You want to write the structure means you write. I'm not specifying it. Solve this.
SP3, sir.
sp3 right?
Tetrahedral, sir.
Tetrahedral correct.
No pairing
N
occurs.
equals to 1.
No pairing occurs. Okay. Any unpaired electrons?
One unpaired
One unpaired electron, sir.
One unpaired electron correct.
Mu equals to 1.73.
Equal
Paramagnetic.
1.73 Bohr-Manhattan correct.
Paramagnetics.
Paramagnetic correct. Copper plus 2. Copper actually 4s1 3d10. Copper plus 2 means 3d9. One, two, three, four, five, 6, 7, 8, 9. 4s, 4p, sp3 hybridization. Cl minus weak field ligand. Outside orbital utilized sp3 tetrahedral. Unpaired electron 1. Mu value 1.73 Bohr-Manhattans. Paramagnetic. Correct.
SP3, sir.
Adra?
SP3. sir.
sp3 you are expecting na? Here exceptional thing is there. Exceptional. Okay. Over properly. Copper plus 2 again. Copper plus 2 means 3d9. Na? So what we have to say? This is 3d. 4s. 4p. But Pauling suggested that that extra unpaired electron moving to P dsp2 hybridation. So square planar Cu plus 2. You don't need to represent every time date you want. Simply also you can write. Simply also you can write. Square planar that 90 degree, 180 degree, one angle. N value 1, mu value 1.73, same details. Paramagnetic. But only the difference is unpaired electron shifted here. Actually, Pauling, he not gave directly theory. He verified the experimental detail. He verified magnetic moment. Verified the bond angles. He know the structure. He know the answers. To get these answers, their electrons I have to keep freely or pairing I have to do. To get this structure, what hybridation required? Accordingly, he arranged and giving the explanation. Bond angle 90 degree he got. So that should be square planar. I should not write sp3, but here d required, but d electron there. That disturbing me, na? I will keep that side. dsp2. Now everything matching. Like that only he explained. Actually, you don't know which is strong field, which is weak field. Why pairing occurs, why pairing not occurs also he not explained. That is the demerit of this theory. Pairing, why occurring, why not occurring, what is the basis for electron pairing, he not explained. We don't know. He is telling pairing occurs or may not, may or may not. Here I got result mu value 0 means electron pairing only. Mu value something I got, so electrons not paired. From experimental data, he developed the theory. We are learning a reverse way. Actually, the strong field, weak field, this discussion is next theory, crystal field theory there. They are given that knowledge we are using to understand this VBT theoretically without checking the experimental detail, without taking the experimental detail. With the theory only we are going to answer. But some cases we are getting like this problems. And scientists objected a lot about the explanation of this copper ammonia complex. That is square planar, correct, confirm. Bond angles confirm. Mu n value confirm. Only problem is to get square planar sp3 he cannot write. For that he shifted the electron. That scientist's objection is, Ara Babu 3D 4s means koncham similar energy there. So 4s to 3D, 3D to 4s electron moving means little bit extra energy only, na, they can get. Okay, we will accept. But how is the moving to 4p? 3D to 4p means definitely much difference in the energy. How that is moving to that place? Who gave the energy? Okay, for example, if it got energy from other source and finally excited means, being this electron is highly energetic, with further little bit supply of energy, this electron should be given out. If electron given out means Cu plus 2 will become
Cu plus 3.
Cu plus 3. When we are trying, that became impossible thing. Cu plus 3 not at all forming. Means Pauling, what you said that is wrong. As square planar, okay. As you no need to say we have done an experiment means then also we will also get. You no need to say from your theory. Square planar confirm. Unpaired electron, 3D9 configuration means definitely one unpaired electron. Whatever the pairing occurred or not occur, whatever thing. Adi also, we not anything from you. Square planar confirm. But how the square planar coming? You are giving some explanation, but so many objections there. So Pauling hands up. Not covered the proper explanation here. Later, some other scientist, Huggin, name Huggin, he said that electron not jumping to 4p, here only present. sp2 next 4d D, sp2d hybridation, square planar like that he explained. But the extra information for you not required, and you no need to read that point. Why? Because NEET exam wise, copper ammonia complex means hybridization. You have to say DSP to square planar. What is the latest update? Adi not required for NEET. Advanced required there they will say SP2D. But NEET example it appeared means you have to say DSP2 only even though you have further knowledge. Okay. NEET level DSP2 square planar. And they are asking about regarding Pauling. Pauling what set we are asking here? Then DSP2 square planar you have to say. Okay. This only remember. Special case na star mark. Like this so many demerits there. So many cases there. He not explained about strong field, weak field. What is the criteria for electron pairing? Not explained. Why some cases like this happening? Not explained. This complex na perfectly he not at all explained properly. Like this, so many objections. But so many things we are learning from VBT also. VBT also giving explanation for so many things. But some cases are abnormal is there. After that, crystal field theory, next ligand field theory. No theory is 100% correct. No theory is 100% correct. Every case, positives there, negatives there. Got it? Write this written ara.
Yes, sir. Wrote, sir.
Okay. Next, isomerism. Isomerism. Isomerism means what? Existence of
Different
two or more
structures.
Same
compounds with
format, different structure.
existence of two or more
Same
different
format.
compounds with same
Same
molecular formula.
molecule.
Molecular formula same. There are two types ra. Structural isomerism,
Functional.
stereo or spatial isomerism. You can say space isomerism also. Again, two varieties there. We are going to discuss here. Organic chemistry, inorganic chemistry, complex compound. Not all those you learnt in organic chemistry. Those many things not coming. Okay. Geometrical isomerism, optical isomerism there. But this structural means basic structural difference. Stereo means three-dimensional space difference is there. Basic structure same, only three-dimensional space how they are arranged are the only different. Geometrical, optical, further everything we will discuss. Right, this.
Completed.
First one, structural isomerism. There is difference in.
Sir, your screen is lagging.
Lagging here.
Sir.
Maybe net connectivity. Written up. Previous thing once again I will share this. Okay. ఇది completed.
Yes, sir. Yes, sir.
Structural isomerism. There is difference in basic structure. The main structural difference are there. In that, first one, ionization isomerism. Right there, it is due to the exchange of ions in and out of the coordination sphere. Exchange of ions in and out of the coordination sphere. Exchange of ions. Very simple to answer. In this two, you see bromine and sulfate groups exchanged. Br minus and SO4 2 minus. They exchanged ions in and out of the coordination sphere. In and out of the coordination sphere, ions are exchanged. Are they different compounds?
Yes,
How can
Yes,
we
sir.
prove that? Means here, ఇది with aqueous barium chloride. ఇది will give BaSO4 wide PBD ra. Wide PBD formed. ఇది with excess AgNO3, aqueous AgNO3, no PPT formed. ఇది with aqueous barium chloride, no PPT formed. ఇది with aqueous AgNO3, AgBr, pale yellow PPT formed. Means property is different or not?
yes, sir.
Different, sir.
So these two are appearing superficially same. ஒரு cobalt, 5 ammonia, ஒரு bromine, ஒரு sulfate. But the basic structure is different. Properties are different. Means these are different compounds with same molecular formula. Ankshita. Understand the difference? You want to write more examples means without any difficulty, very easily how can you manage without by heading? I will say the technique you see. Bromine plus la chlorine you take. Bromine plus la chlorine you take, ra? Another example came na. Further more example you want to write. Cobalt plus la chromium you keep. Cobalt plus la chromium you keep. Further examples you want. Ammonia plus la water you keep. Ammonia plus la water you keep. Any number of examples very easily you can write. You no need to by head the example. Then one more thing here. Cobalt plus 3 Nara here present. Cobalt plus 3 or not?
Yes, sir.
Cobalt plus 3 coordination number generally how much I said ra?
6.
6. Here 5 ammonia, 1 sulfate. Actually sulfate bidentate, monodentate.
Bidentate.
Bidentate means cobalt plus 3 here coordination number how much it becoming?
Plus 7. 7.
But 6 only coordination number. Why? Because sulfate group here monodentate. So it is called as flexidentate. Here it act as monodentate ligand. It is having capacity to donate 2 electron pairs. But here requirement 1 electron pair only, so that 1 electron pair only donating. Like that also possibility there. So the polydentate ligands which can change their denticity based on the demand. The polydentate ligands which can change their denticity based on requirement or situation. Flexidentate ligands. Flexibly they are changing their denticity. Called as flexidentate ligands. Here SO4 minus act as monodentate ligand. Actually it is a bidentate ligand, so this is called as flexidentate ligand. Got it? So what is flexidentate ligand? Polydentate ligands which can change their denticity based on requirement. Polydentate ligands which can change their density based on requirement, called as flexidentate ligands. Examples. Best example EDTA4 minus Ra. Hexadentate, but it can change its density a lot. Next example, sulfate group, what you have seen now. Write this.
Completed, sir.
Completed overall.
1 minute. Completed.
Completed, sir.
Wrote, sir.
Sir, 1 minute, sir. Yes, sir. Completed, sir.
Leader. Next, hydrate or solvate isomerism. What is that? Hydrate or solvate isomerism. This is like ionization isomerism. There ions exchange. Here ions with water molecules exchanges. This is due to the exchange of water molecules in and out of the coordination sphere. So there are water molecules in and out of the coordination sphere, they are exchanging. This isomerism is called as hydrate or solvate isomerism. You want to write more example means what you will do, Ra?
Exchange Cl with Br.
Chlorine place lo bromine you can write. Further, Ra?
Chromium place cobalt.
Yes, chromium place lo cobalt you can write like this. Okay.
Completed, sir.
Okay, right, Ra. Thank you.
Sir,
Ah, sir.
sir, can you show this flexible ligand definition alone, sir?
Which one, Ra?
Flexible ligands.
Okay, is it written are all of you?
Yes, sir. Thank you, sir.